All right, so I wanted to give everyone a week before I actually made an announcement, or I guess an explanation video of the project, to give people some time to look it over and ask a few questions. And I've gotten a few, not a ton, so I'm hoping people have taken a look at it. If not, I'm going to go through it. I'm more going to go through in detail what requirements I'm asking of you for for the final project when you turn it in, and kind of how I'm going to approach grading so that you know what you need to focus on for this project, because there are a lot of requirements, a lot of detail in here. And so just to quickly go through the overview, this should start to look somewhat familiar, at least the format. So what I've got here are two differential equations, and they are representing at a very high level kind of the basics of electric motors. You have a current equation and you have a rotational speed equation, and they are coupled, right? So you have current and omega in the rotational speed in both of them. And so there's a lot of variables in these equations, so I gave you a nomenclature for all of it. So go take some time, look through it. I gave you the values and the units, and effectively you need to have a basic understanding of electric motors for the first part of the requirements. I'm getting a little ahead of myself, but effectively the goal of this is I'm going to give you everything in these equations except for L, which is the inductance of the motor, and I, which is the moment of inertia of the motor. And those are both effectively representations of how quickly the current can respond and how quickly the rotational speed can respond, right? So moment of inertia affects effectively like time constants and things, how quickly that thing can spin up or slow down, and then the inductance is a similar thing for the current and how that can change to different voltages and things. And so I've given you some constants in here, and effectively that makes these two equations boil to equations 3 and 4. And so I've given you two initial conditions because you need them for IA and omega. And I've given you all the variables you need except for LA and I. And so the goal is to find a value of LA and I for the solution I gave you. So I gave you two plots here, and then I also uploaded to Pilot this data here, where I have time, current, and rotational speed. So this is effectively the data that makes up these two plots. And so your kind of technical goal is going to be use Simulink, an ODE solver in MATLAB, a script you make up to try to find some way. It's very open-ended, to find some way to match this response within 10% of the value for LA and I. So basically, you're aiming to try to find those values within a pretty small margin. And so that'll give me, like, I can just compare your number to what I have. I have the values of both of those for that data, obviously, because I generated the data. And so I'll have that, and that way you can I can grade it quickly, but you need to be able to get to a pretty close value there. And so I've got this response for you, I've got this data. And so how you do it is almost entirely up to you. And so let's go through the project requirements, and then I can give you some pushes in the right directions and things. And maybe there's a lot of ways that I saw students do it last year. And how you do it doesn't really matter to me. You just have to be able to actually actively describe it. And so that gets into these project requirements. And so first I want you to do, First, I'm going to need you to complete a preliminary research. That's part 1 here, basically into different applications and modeling techniques for how to represent small electric motors. And so I want you to have 5 sources, 2 of which must need like some sort of academic source. And I know access to library is going to be hard, but all of you should have access to like the Wright State Library databases. So you should be able to find like journals and conference papers and even e-textbooks. Honestly, you can find all of that. And if need be, you can go physically into a library or something. Just make sure you're being safe about it. And if these kind of pose problems to you, let me know, and I can always relax this requirement. But I want it to be there because I think it's reasonable for you to, with the internet, find good academic sources. There's plenty of them out there, I promise you. And Wright State does give you access to a lot of them, so you might want to contact people about that because there are ways for you to do that. And that's kind of part of this. I want you to start learning how to do research, do basic research, and do basic writing, technical writing. So from there, that's just like an overall for the report, kind of getting you some information on how electric motors work. And they are electromechanical systems. So I know pretty much everybody here is an electrical and is a mechanical engineer, but there is a mechanical aspect to them as well. They're a pretty big thing in the aerospace industry and in a lot of industries, and in the automotive industry as well. So getting to know what they are is honestly going to benefit you too. So requirement 2 is what I just mentioned, and this is going to be a big part of your grade. I think I ended up having it be, I don't know exactly, but of these requirements, this is going to be a big chunk of it. So probably about maybe 20% of your final grade is in the project is going to be getting to correct values of LA and I. So to get the same solution I posted here and I posted in the data on Pilot. And so it's going to be a big chunk of your project. So if you can't get to it, or if you can't get there, get as close as you can. And I will give partial credit. Right? Like there's going to be, if you get like most of the way there, I'm not going to like dock you the whole 20%. But this is I'm just kind of trying to drive home the point. This is the big part of your project. And from there, I need you to prove to me basically you know how to do basics in Simulink and MATLAB using these things. So what I want you to do is create a MATLAB script file that uses these two values to solve the equations and get these results, the results for the current and rotational speed, using both MATLAB ODE solvers and Simulink. And you need to execute them from the same script. And so if you don't know how to do that, you need to learn how to do that. And that's part of this. And again, if you really need help, if you're getting to a point where like you can't figure it out, you can email me. But these things are on the internet, so just go look at them. But the real question from this is how do you execute Simulink from a MATLAB script? It's actually really easy. So if you go to search them, you should find a pretty good solution. Like I said, if you get stuck, you can ask me or the TAs during office hours. And so basically, if they're in the same script file, it means Simulink should be called from the same MATLAB M file that you're using to solve the equations using an ODE solver. And I don't want you to plot it using a scope block. You need to compare the Simulink solution to the MATLAB ODE 45 solution. I don't want you to plot it using a scope block. You need to actually plot output variables, current and rotational speed to the MATLAB workspace, which I've shown you in some of the videos, in some of the lectures, and then plot them and compare them to the solution using ODE 45. And then what I want you to do is that Simulink model should use a fixed step solver. I just posted a video on how to change from a variable step to a fixed step solver. And the variable step solver should be used in the MATLAB script. So you should use ODE 45 or another variable step solver method. There are multiple out there. And then from there, you should basically recreate these plots, but they should have a comparison. So there should be one step ahead. You have the solution, then you should have a comparison between the Simulink solution with a fixed step solver and the MATLAB ODE 45 or ODE solver solution. And then the last task, which is going to be worth the least. So each of these is going to be worth basically a few % of these grades. So like effectively all of this, the calculations and everything here are going to be worth 40% of the total grade on this project. Basically, half of that is going to be finding the correct values of LA and I, and the other half are going to be following every one of these steps. So if you don't have one of these things included, I will dock you points for it. But I'll tell you, not doing this part is going to make you lose less points than number 2 here. But the last part is going to be you should explore the effect of using a larger step size on the solution of the two equations. So basically, when you have that Simulink model, you have a fixed step solver in Simulink. As I showed you in the example I did and posted, the extra example I did and posted on Pilot, as you change the step size, it changes the solution. So basically what I wanted you to do is do that in some way using Simulink and then plot it and include it in your report. And getting to that, so I did going to be 40% of your grade. So where does the rest of the grade come from? You have 60% left. Well, the other 60% is this. You have to complete a final report. It's a technical report, no shorter than 6 pages, double spaced. And then I added a caveat: figures may not take up more than 1 page of this space total. I did get a question. It's like, okay, well, what exactly does that mean? Can I not have more than two pages of figures at all, or 1 page of figure at all? The answer to that is no. You can have more than that, but you basically have to have 5 pages of actual completed text. That does not include your appendix with your Simulink code. It does not include your bibliography, which I'll get to in a moment. So you need to complete a final report. And it's basically going to include this part here, this preliminary research that's going to be in your introduction sections, and then basically going through the steps on how you completed your solution. So no matter what you do to calculate these values of LA and I, you have to give a detailed explanation in the report. And part of that is, to me, that you didn't just like have a friend send you the values, right? You have to have a cohesive explanation. Otherwise, I will assume that you didn't actually do it. And so you need to have that there. If you just guessed and checked and took like 5 hours just plugging in values until you find the right answer, that's fine with me. I don't think you should do it that way. That's not the best way to do it. It's not using all the tools we've learned of in class. But you can't do it that way. You just need to give me steps, basically. You have to prove it to me in that report that you've done it and show me that you did it. Show me some intermediate steps, like, hey, maybe you took 5 hours, and in what points did you kind of figure out that you were going in the right direction or the wrong direction? Put plots, show me the values that you came up with as you went along, and things like that. So you have to give me an explanation that seems valid, right? Like it seems reasonable to me, the reader, in there. And so, getting to more details of that report. Well, I guess I'm gonna go over this note too. Even if you don't get the right answer, right? You don't get close enough. You think you get somewhere, but you don't get anything. But you solve the equations. You just didn't get the values for LA and I. That's perfectly fine. Just still include everything you did in the report. That way you can get the points for the report. The report is not going to, I'm not going to dock points off of the report if you get the wrong answer. That doesn't matter to me. What matters to me is that you're explaining everything you did. If you get to a point where your results just aren't right, that's fine. Just say that. Just like that's what you do in the real world. If you don't get to the answer you were looking for, sometimes that's okay. I mean, in this solution, in this instance, there is a correct answer, but in the real world, like sometimes there isn't. You just can't do what you're aiming to do, and maybe you could get most of the way there, and that's still worth something. So you need to include that in your report. All right, and so the last 2 things before I get to the report template, the project is going to be due Friday, December 11th at 11:59. So that's the Friday of finals week at 11:59 p.m. I would give you more time, but that I have to have grades in by Wednesday of the next week. So that should hopefully give you some buffer in finals weeks. So you can put off things to study if need be. But that being said, this is on the Friday of finals week, so you need to have started beforehand more than likely. So make sure you start to work on this as soon as you can. There's going to be kind of a gap in lectures and stuff over Thanksgiving break. So I hope that you're gonna take advantage of that and at least begin working on this. And then the last thing before I get to the template, I've given you here your values of LA and I are within these bounds. So I wanted to give you bounds of it. They're still really big bounds, but if you go outside of these, like if you go less than 0.01 for either of them or greater than 2 for either of them, you can cause an error in the solver in Simulink or ODE45. And so you need to stay within inside those. And that also gives you a space to search, right, to look for the right answer. All right, so I've given you a pretty detailed report template. So you need to have a cover page nomenclature. Those do not count towards your 6-page total. Your 6-page total should only be sections 3 through 7. Right there. Oh, and I didn't include it in here. You should include bibliography. You should include a works cited based on the 5 sources you found. Yeah, and so that's kind of that. I probably should have added that, but that should be there as well. But so basically, I've given you details. So you have an abstract, which is effectively like it's effectively a 300-word or less description of what you're going to find in the report. That usually includes like a summary and then what your kind of final results were. Just take a stab at that. I want you to try to work on it. I know that those who have taken EGR 1010, you have to do that for all your labs, or at least you used to. I assume they still have you do that. And anybody that's taken tech writing should recognize a lot of this. Then I want you to have an introduction where you have to state the problem, constraints, overall plan. So this is going to basically be restating effectively the problem I gave you. Restate what that problem is in your own words. Don't copy and paste it, because I will find that. I will see that. I wrote the problem. I know what it looks like. You need to restate it, how you understand it, what the constraints are, and what your plan of solution will be, and not in detail. And then you need to include your research that you gave on motors, on electric motors. Then there's a methodology section. It outlines the solution to the problem and the method you took to get there. So effectively, what is your solution? What is your kind of goal to get to the solution? Any results, including like what your values of LA and I, should be in the results and discussion section. So this is any results, any plots or anything like that should be in results. Methodology is just explaining how you got there. So like I said, explaining the method for how you got to LA and I. And then also showing how did you go and do some solver comparison? How did you run both the Simulink and MATLAB solver game script? Everything like that. How did you do it? And then what you got from it is here. And so I gave you some kind of basically what needs to be included in each section as well, in very detail, in some more detail. And the conclusion, honestly, is usually similar to the introduction. You basically reiterate the problem. What were you doing? A very brief explanation of how you solved it and what the results and conclusions were from what you did. And so that's what you need to do. And so basically the way I'm going to be grading this, as I said, this is going to be worth 60% of your total grade, which means you have to include every section of it. In my rubric, I've kind of broken down each section into points and things. So you have to include every section. Not only that, you have to include everything I'm asking you to include here. I gave you a very detailed template and outline. Follow it and include everything. And if you write even decently well, I know that you all are probably early in your collegiate careers, at least somewhat early. It doesn't have to be polished, it has to be perfect. I just want you to include every section and take your best shot at it. This isn't a technical writing class. I'm not going to grade you for how well you wrote it. You just have to include everything and kind of convey it to me, explain it to me in a way that I should be able to understand pretty quickly. So if you include everything in this template, you should get all of the points for the exam. Not for the exam, for the final project report. So again, this report is 60%. And everything that I showed you in the project requirements here, basically parts 2 and 3 here are worth 40% of this grade. And I think this total final project is worth 20% of your final grade. So you can break out what you might need to do to get an A, B, C, whatever in this class. But that's kind of a summary. And so hopefully this helped. Hopefully this gave you a more detailed explanation and what I'm kind of wanting you to do with this project. If there's questions, as usual, I'll be at my office hours on Monday, Wednesday, and till the end of the semester. And if you can't get to those or for whatever reason, feel free to email me, ask me a question. I can always do follow-up video, talk with you one-on-one, send email back and forth, whatever we need.